Alright, welcome back. So we were discussing this optimal nonlinear pricing. What we want to do is to find the optimal pricing scheme among all possible pricing schemes, right? So that's quite a difficult task, but last time I claimed that it is enough to consider a direct mechanisms which satisfy the IR and IC constraints. Alright, so I talked about revelation principle, and I claimed that the IC and IR constraints are necessary conditions, so they must be satisfied, and you cannot increase the profit by adding more constraints. So we want to just consider this. We want to find the direct mechanism that satisfies the IR and IC constraints, which is basically just this problem that you see in this slide. So the monopolist post QL, TL, and QH, TH to maximize this objective function, the profit function, which is half times TL minus C times QL plus half times TH minus C times QH. Subject to the four constraints. These are the IR and IC constraints, right? So these constraints must hold, and we don't add any more constraints. So this by solving this problem, we can characterize the optimal pricing mechanism, pricing scheme. Okay. So how do you do that? How do you proceed? We have done this for the task allocation problem, so it is basically similar. So we have four inequality constraints. So the first step would be to figure out which constraints are binding and which constraints are not binding, or which constraints are important, which constraints are ignorable. That's the first step. That's what we want to do first. The first thing that you can do is you can rule out the IR constraint for high type. The reason is this. You see on the top the IC constraint for the high type. The IC constraint for the high type says that theta H times VH minus TH must be greater than or equal to theta H times VH of QL minus TL. So the high type consumer is better off by choosing high type option than choosing a low type option. So this is the IC constraint, the incentive constraint, right? And in the next line you see that the theta H VH is replaced by theta L times VL, and theta H times VH is the utility that the high type consumer enjoys when consuming QL, and theta L times VL is the utility that low type consumer enjoys as QL. And theta H VH is larger. Theta H is larger than theta L. So, and high type consumer enjoys this good more than the low type consumer does. So theta H times VH is larger than theta L times VL. So and TL is same. And the last step is theta L times VL minus TL must be greater than or equal to 0. This is the IR constraint for the low type. And if you compare, if you see this sequence of equations, inequalities, you can see that you reach to the conclusion that theta H times VH of QH minus TH must be greater than 0. It's strictly greater than 0. What that means is the IR constraint for the high type consumer is satisfied as a strict inequality. It means it doesn't hold. I mean, it doesn't bind. We can ignore it because it's not binding. So non-binding constraint can be ignorable. So IR constraint for the high-type consumer is ignorable. So we are left with the other three constraints: the IR constraint for the low-type consumer, and the two IC constraints. And then we have to figure out which constraint among these, which constraints are not binding, which constraints are binding. And for that, we draw this diagram again, which looks very similar to what you saw before in test collocation, right? So here we take QL and QH as given. So we fixed QL and QH, and we draw this IRL, ICH, and ICL on this TL, TH plane, TL, TH on this TL, TH space. We draw IRL and ICH and ICL constraints. Okay, so IRL requires that TL to be small enough so that the L-type consumer participates in this deal. So if TL is too large, the price that the L-type consumer must pay is too large, then L-type consumer will not participate in this deal. So you see that TL should be smaller than a certain value, and you can see that ICL and ICH can be drawn like this. ICH is above the ICL, and it requires that TH to be small enough, otherwise the high type consumer will deviate to the low type option. And ICL requires that TH to be large enough, otherwise L-type consumer will deviate to high-type option. So graphically, you can see that this is the IRL. So IRL requires that TL to be small enough. It must be smaller than theta L times VL of QL. And this is ICH. It requires that TH to be small enough, otherwise high-type consumer will deviate to the low-type option. Okay, so TL shouldn't be too large. And this is ICL. So ICL requires that TH to be large enough. If TH is too small, then the low-type consumer may want to buy the high-type good. And this is the area all three constraints are satisfied, right? So this green area is the area where all three constraints are satisfied. And on this, we can draw isoprofit curve as we did before. So it looks pretty similar, but you can see that now we want to increase T. So in test collocation problem, we are discussing, we are talking about wages. So we wanted to reduce wage as much as possible. What that means is that we want to push down the isoprofit curve as much as possible. But here we are talking about the prices. The seller is maximizing the profit by increasing prices. So here we can draw the isoprofit curve, and we want to push out the isoprofit curve as much as possible. So what does it look like? What does an isoprofit curve look like? So isoprofit curve can be derived like this. So half times TL minus C times QL plus half times TH minus C times QH is price. And let's say that price is determined by pi. So the level of profit is as pi for any given number pi, we can draw a isopropy curve. So isopropy curve shows that the TL and TH pair, which gives the same level of profit. So in this diagram, it can be drawn like this. So the slope is -1, and yeah, for any given level of profit pi, so it can be drawn like this or like this. But we want to push this isopropy curve out as much as possible. So this is the maximum. So this is the farthest we can go, right? So the profit must be maximized in this black dot, in this black point. As you can see, there the IRL and ICH are binding. So IRL and ICH must be binding at the optimum. So we have this problem. So the monopolist posts the quantity and price pairs to maximize the profit, and the choice variables are TL, TH, QL, QH, and we have 2 binding constraints. So we started with 4 inequality constraints, and we figured out that only 2 of them are actually binding. And the 2 binding constraints are IRL and ICH. The IR constraint for the low type consumer and IC constraint for the high type consumer. And if you solve this problem, then you get this equations at the bottom. So for the low type consumer or QL, the first equation must be satisfied. 2 times theta L times VL prime minus theta H times VH prime must be same with C, marginal cost. And for the high type good, QH must be given, it must be characterized by this, theta H times VH prime equals to C. Okay? So how do you get this? There are multiple ways. So for example, you can write Lagrangian, and you solve the Lagrangian to find the optimality conditions, or you can just replace TL and TH using the IC and IR constraints. And so because you use the constraint, we already imposed the constraints, and we eliminated this TL and TH. We have this unconstrained maximization problem with the choice variables QL and QH. Okay, so you just solve this unconstrained optimization problem. So first you differentiate this objective function with respect to QH. Then it's quite simple, right? So if you differentiate this objective function with respect to QH, then you get theta H times VH prime minus the marginal cost C. So the left hand side is just the first derivative, and the right hand side is 0. So you set the first derivative equals to 0. So this is the first of the condition, and yeah, it's quite simple. So theta times VH, theta times V prime is the marginal utility, and C is the marginal cost. So marginal utility equals to marginal cost. That's how we maximize the social surplus, or that's maximize the social surplus. The second situation, the second case, is more complicated. So you differentiate the objective function with respect to QL, then you get what? First, you get theta L times VL prime of QL, and then you have marginal cost C, and you have more. You have the terms in the square bracket. Theta L times VL prime of QL minus theta H VH prime of QL equals to 0. So if there is no the terms, if there isn't the term in the square bracket, the expression would be very similar in the two equations, to the two first order conditions. But because of this expression in the square bracket, we have a different, quite different equations. So let's try to understand the second equation. The first equation looks simple, so let's try to understand the second equation. So this shows what happens when you increase QL, right? So you differentiate this objective function with respect to QL. So what that means is you increase QL by 1 unit. Then the profit changes in this way. So you increase QL, then you can increase TL, right? So you increase the quality of the good, quality of the low type good, so you can increase the price of the low type good by theta L times VL prime units. Okay, so you increase QL, then you can increase TL. So that's the first term. That's what the first term represents, right? So the first term means that when you increase QL, you can increase TL as much as the marginal utility, so the increase of the utility. And then the production cost, the second term, the production cost increases as much as C. So that's the marginal cost. So the production cost increases. And then you have the terms in the square bracket. We have these terms because of the binding IC constraint, because of this information problem, asymmetric information problem. Because of the asymmetric information problem, you cannot distinguish the high type consumer from low type consumer. That's why we have to impose IC constraint, and unfortunately the IC constraint is binding and it affects the solution of this maximization problem. That's why we have this expression in the square bracket. So let's look at the first term in the square bracket. So when you increase QL, you can increase TH as well because you increase TL. So let me repeat. You increase QL and then you increase TL, so you can increase TH as well, right? So because now the low type good is more expensive, so you can increase the price of high type good. So that will increase the revenue. So that's the additional benefit. So that's what the first term in the square bracket represents. But we have the second term in the square bracket. Then you have to decrease TH as much as theta H of VH prime of QL. What does this mean? So it means that because you increase the QL, now the low type good is more attractive to the high type consumer, right? So the high type consumer appreciate the quality more than low type consumer does. So if you increase QL, then high type consumer is attracted to the low type good more than the low type consumer does. Sorry, more than the low type consumer is. So you have to decrease TH. So when you increase QL, then you have to decrease TH. Overall, you have to decrease TH. Otherwise, the high type consumer will deviate to low type option to buy the low type good. So that's what this equation means, right? So the first two terms is the terms that we just saw in other equations, like in the first order condition for high type consumer. But we have the expression in the square bracket because of this binding IC constraints. So in order to this high type consumer keeping this high type consumer away from the low type good, you'll have to reduce TH. What that means is there is an additional cost of increasing QL. Thus, in equilibrium, in the second best situation, you don't want to increase QL as much as you did in the first best situation. So the second best QL will be smaller than the first best QL. So let's compare the first order conditions more directly. Like the first in the first best situation or in full information benchmark, you have just simple expressions. On the left hand side you have the marginal utility, on the right hand side you have the marginal cost. This is the socially optimal. You saw this in this, right? So at the bottom you have the expression that on the left hand side there are marginal utilities, on the right hand side there are marginal costs, and these two equations, the two equations at the bottom are exactly the same equation on the top. So the first two equations are equivalent to the last two equations. So that's the QL and QHFB, the first best quantity, and now we have this. The first best are given by this, and the second best looks a bit different. So for high type consumer, they are same. So QHFB is same with QHSB. So for high type consumer, the quantity demanded or quantity consumed are same in the first best and in the second best. But the low type consumers quantity or quality are different. Is different from the first best situation, right? What that means is the QLSB is inefficient. QLSB is inefficient. So QLSB is smaller than QHSB, and we saw similar results in test collocation, and that can be expressed like this: efficiency on the top. So this is a typical result in adverse selection models. So for the high type consumers or high type workers, the efficiency is achieved, but the lower level transactions are distorted. So high type consumer consumes at the optimal level, while the low type consumers consumes below optimum. And the reason is this: the seller wants to earn profit as much as possible from the high type, but if the price TH is too high, then the low type option will be chosen. So but you don't want to reduce TH too much. So instead you reduce QL and TL. So you distort the low value transaction. So you lower the value of low type good, and by doing that you keep this high type consumer from low type option. So it's like it's like the economy class in airplane. So economy class is really horrible, and it doesn't have to be that horrible, but if economy class is bearable in terms of quality, then the business class people will choose to buy the economy class. So in order to make this business class consumers buy the business class ticket, the airline will lower the value of economy class. Okay, and there is some new term I want to introduce, which is information rent. So the seller leaves some information rent to the high type consumer. And what is information rent? What is rent? Rent is an income from ownership or property right? So there are three types of income, right? So the first type is profit, and second wage, and third rent, right? Wage, profit, rent. Wage is the income from working or labor, right? And profit is income from running a business or investment, and rent is a profit from having something. So if you have a real estate, then you lend that property to someone else, then you get rent, right? So that's what economic rent is. That's what rent is in narrow definition. In broader definition, economic rent is an income, or is a surplus that you get because you have something. So information rent is the rent that you get because you have information. So high type consumer has a valuable information. So in a sense, the seller is paying the rent to the high type consumer, so that the high type consumer reveals that information. What is that information? That information is that he or she is high type. That's the valuable information. To make the high type consumer reveal his or her type, the seller must pay the information rent. So that's the surplus that the seller must give to the high type consumer. So how can you see that exactly? If you see the IR constraint, the high type consumer's IR constraint is not binding. That means some surplus is given to the high type consumer, right? Let me repeat. So the low type consumers, let's consider low type consumer. Low type consumers' IR constraint must be binding. So what that means is the low type consumer's surplus, the consumer surplus, is zero in equilibrium. The low type consumer gets nothing. But high type consumer's IR constraint is not binding. It holds as strict inequality. What that means is the high type consumer enjoys some surplus, and that's called information rent. And you can understand it in this way. So the seller must pay some rent for that information, the valuable information. The valuable information is that the high type consumer has, is that the high type consumer is the high type consumer. So that's the valuable information. Okay, so that's why the seller must pay the information rent. Okay, and in general, QHSB is greater than QHTP, but it's not clear whether QLSB is greater than QLTP. TP stands for two-part tariff, as you know. Alright, that's it for today, and next time I will discuss auction. The difference between auction and price discrimination is that in price discrimination, the seller can provide the good without any limitation. So if someone needs something, then the seller just simply produces it. But in auction, there is a clear limitation in supply. So, for example, like selling Picasso painting, obviously the number of Picasso paintings is limited. So in such a situation, the buyers must compete to buy the available good. So in that case, the auction mechanism or auction model is more proper to consider. Okay, so that's it for today. Bye.